Okay, welcome to our lesson on negative exponents. So in the previous video, we defined a zero exponent. So we said like 2 to the power of 0 is equal to 1, or anything to the power of 0 is equal to 1. But now we want to define like what it would be 2 to the power of, say, negative 3. So remember, exponent means multiply it that many times. So what exactly does that mean, to multiply negative 3 many times? So it's a little bit different than if it was a positive number. But we're going to get this the same way we got our zero exponent. So just recall that exponent law, the division law, that x to the power of m over x to the power of n is just equal to x to the power of m minus n. So we use that to get the zero exponent. Well, now we're just going to do the same thing for a negative exponent. So let's say we had 2 to the power of 2 over 2 to the power of 5. And then we're gonna solve this question in two ways. So the first way, we'll use our exponent laws. So using exponent laws, that would be 2 to the power of 2 minus 5. So because it's division, 2 minus 5, which is 2 to the power of negative 3. So this expression is a negative exponent. But we can also solve this by just expanding the exponent. So by evaluating the exponent first rather than using exponent law. So 2 to the power of 2 is 4. Actually, let's not do that. Let's just write out what 2 to the power of 2 means. 2 times itself 2 times. So 2 times 2. 2 to the power of 5 means 2 times 2 times 2. And then 5 2's. So there are 5 2's. And then you can simplify this, right? We have a 2 on the top, which divides with one of the 2's on the bottom. 2 on the top, which divides with another one of the 2's. So we've divided both the 2's on the top, so we're left with just a 1 on the top, and then we have 3 2's on the bottom. So 1 over 2 times 2 times 2, which is equal to 1 over 2 to the power of 3. And yes, you could write that's 1 over 8. But the connection that we're going to make here is these two things must be the same, right? Since they started as the same. So that's how we're going to define our negative exponents. If you notice, it just becomes the reciprocal. So if x to the power of n, where actually let's put x to the power of negative n, where n is an integer, then if you want to make the exponent positive, all you need to do is just do what we did here. It would just be the reciprocal of x. 1 over x. I don't need the bracket really. 1 over x to the power of n. Okay, so that's how we do negative exponents. So just some examples. 5 to the power of negative 2. That would be equal to the reciprocal, 1 over 5 to the power of, and then the positive, which, if you want to evaluate, would be 1 over 25. You could have negative numbers, let's say, or negative bases. Negative 3 to the power of negative 4. Well, that would be, we want a positive exponent, so all we do is take the reciprocal of the base. So the reciprocal of 1 over of negative 3 is 1 over negative 3. And then this, you could actually do it all to the power of 4, or you could just do the base to the power of 4, because 1 to the power of 4 is 4. And then you can multiply out. This is all really the main thing you're going to have to do, but if you want to actually evaluate that, would that be 81? more examples. Let's say we had a fraction. Let's say we had something like 1 over 2 to the power of negative 3. So here, you want this to become a positive, so you have to do the reciprocal of this. So what's the reciprocal of 1 over 2? The reciprocal of 1 over 2 is 2 over 1, and then the exponent becomes positive. So really that's just 2 to the power of 3, which is 8. Okay, so it's gonna, if you already have a fraction, it's just gonna flip it. Let's go up and do some more. Okay. Let's say you've got something like 2 over 5 to the power of, I'm going to keep these. No, it's minus 6. I won't evaluate this one because it's too big, but if I want to change it to a positive, I just need to take the reciprocal. 5 over 2 to the power of 6. And then that would be 5 to the power of 6, which is a large number, over 2 to the power of 6, which you could evaluate if you have a calculator, but I'm not going to evaluate it. And just one example, this is just like a warning example. Let's say you had something like 0 to the power of negative 2. Well, there's a bit of an issue here because we say that if we want to make the exponent positive, then we have to take the reciprocal of this. But what's the reciprocal of 0? Is undefined, right? So you might try to write something like 1 over 0 to the power of 2, but this is meaningless, this is undefined. So that means that this is undefined. So you can't, if the base is 0, you cannot do a negative exponent. And actually, I probably should have wrote that in the initial rule. So here was our initial rule right here. So we should have put x cannot be equal to 0. Okay, so there's just that one exception, and that was it's the same exception for the 0 exponent, right? Your base can't be 0, so you can't have a 0 base for a negative exponent or a 0 exponent. You can for a positive exponent, right? It does work for that, but not for negative or 0 exponents. So that's what you need to know about negative exponents.